All right, I guess we can begin now. So, happy Moram to everyone, and today we are going to discuss about the week 2 materials. So, I hope that you have gone through the materials of week 2, which is spelling correction and language models briefly. So, you have more or less concepts related to these being discussed in week 2, and we shall see some problems related to that. So, like you will be solving some problems, and yeah, so let's start. And once again, let me just remind you, so if you have any doubts, you can write in the message box and I'll respond to them. If we discuss some question in detail, then if needed, I'll allow you to speak through the mic if that is necessary. All right. So somebody asked that whether this session video will be uploaded. Yeah, it will be uploaded. So you don't need to worry about that. And add to smoothing problem. Okay, so we'll see some problems and then we'll get to them. All right. Fine. So let's begin. So I hope the screen is visible to all. And okay. So all right. Uh, So the first question is on uh, Levenstein distance. Can you see the screen changing? If you could just
No.
so the screen is not changing, right? All right, just let me share this once again. So is the screen changing now? Can you see it? If somebody could respond.
Oh, it is the same page.
No, it's stuck in the same. No? Okay, wait.
Yeah, it's changing now.
Yeah. So now I guess the question is visible. So the slides are changing, right? Yeah. All right. So let's begin. So this is the first question. What is the Levenstein distance between insertion and deletion? So the costs for insertion and deletion are 1 each, and the cost for subtraction is 2. So before we start solving this question, we need to remember one thing, that for this question you need to create the table first. All right. And for creating that table, you need to put the two words on the two axes. So I guess you are familiar with this table, where you put the two words on the two axes. So you see that you have insertion on the left hand side and you have deletion at the bottom. All right. And whatever values you can see here, these are the base costs. Like for example, if you see this value 1, it indicates the cost of going from the string I to the string nothing. All right. Sorry, from the string nothing to the string I, and so on. And for example, this number 3, that represents going from string del to string nothing. All right, so you go from the string at the bottom to the string at the left. So horizontal movements are insertions, vertical movements are deletions, and diagonal movements are substitutions. Now I guess you know the rule of how to update the table, like how to update each box. So like, any of you knows how to change that, like how, what is the formula for that? So you can unmute and respond, any one of you. All right. So the rule is that when you change from, when you're trying to calculate this value, say, so then you will look at all the three values. So the cost of this one is whatever you have written in this box plus the cost of insertion. Horizontal movements are insertions. From bottom, whatever you have, with that you add the cost of deletion. And in the diagonal, first you check whether these two characters are same or not. If they are same, you just copy the value of the diagonal. If they are not same, then you need to use the substitution operation. So how do we eventually calculate the value of this box? So first we check whether the two characters are same or not. So in this case they are not same. So we will compare. So the cost we have to compare are, so 1 plus cost of insertion is 1, so 1 plus 1 2. If you go from the bottom, it's again 1 plus 1 2. And from 0, it is you add 2, which is the cost of substitution. So I'll just take a pause, and some of you have been asking about the materials of previous video. So if you have not got it, I'll tell you how to access it at the end of today's lecture. So let us just cover this first and I'll tell you that. All right, so getting back to here, that is how we calculate the value of each box. So first we need to populate the two edges. So these are the base values, and now you need to calculate each value. So let us calculate each row one by one. All right, so this row, if you can see this 2, as I discussed, it can come 1 plus 1 2, or 0 plus 2 2, or 1 plus 1 2, and you repeat the same process for all the other blocks. So you add one with the left hand side, you add one with the bottom, and you add two with the diagonal if they are not equal, like if the two characters are not equal. So this is how we keep populating this. But in this case, if you look at this case where we have both eyes, so this block of 5. So if you look at this one, so in this case, because the two characters are same, there is no cost of substitution per se. We just copy the cost of the diagonal because both are the same characters. So that is why you can see this was increasing in a trend, but then suddenly we go down to 5, and then again the normal rules are followed. So what you need to keep in mind mostly is that you will have to compare the three different costs. So whatever is the value on the of the box on the left, you add the cost of insertion with that. Whatever is the value of the box at the bottom, you add the cost of deletion with that, and whatever is in the diagonal, you add the cost of substitution with that if they are not same characters. If they are same characters, you do not add any cost for substitution, so the value is just like this operation will be just whatever is over here. All right, so you need to compare the minimum of the three possible ways you can reach any box. So from left, from diagonal, or from bottom, and you take the minimum of those values and you put in the box. So that is how we have calculated this row. So we will go on to the next row, which again looks like this. So we are following the same rules over here, and again there is a common, the only case which is different is where the characters are same, so there we copy the value of the diagonal. All right, so uh, this is how we keep populating the values. Remember, you just need to be patient because in some cases you might have smaller examples, words having 4 or 5 letters each, but these are like bigger problems. So in these cases, you need to be patient while filling out the entire table, because remember, if you make a mistake somewhere, especially if you make a mistake at the bottom, it can cascade up to the top. So then your entire calculation will become wrong. So the calculation is not hard at all. It's very simple, but you need to be very patient while doing it, a bit mechanical, and you need to keep calculating the values of each box. So this is, there are many different ways of doing this box. So this is one way in which you have been taught in the in the lecture materials, and so I have followed the similar process. And yeah, so we keep updating the different rows one by one. All right, and do you know how do we finally get the final value of the edit distance between these two words? So where, which box is that, if anybody could answer? Like, I hope you guys are familiar with that. Like, where do we get the final value of this calculation? Yeah, so somebody said the last cell. That is true. So you, what you need to remember is that any cell represents the edit distance between whatever word you have up to that on the both axes. So for example, this 5, that represents the edit distance between DEL at the bottom and INAC at this side. So the edit distance between INAC and DEL is 5. So that is how, what each box represents effectively. All right, so let us just fill up the remaining values. So yeah, so the final answer is 7. This is how you will get it. So that is in the top right corner. All right. So once again, I'm repeating very simple steps. You need to do the calculation for each cell. You know what are the steps to do the calculations. Just check whether the two characters are same or not. Based on that, the cost of substitution will change. All right. And you keep on populating them patiently until you reach the top, which is the final answer. All right. So let me move on to the next question, which is also related to this, and then maybe I can take up some doubts related to this topic if necessary. All right. So the next question is regarding optimal alignment. So the question asks you how many insert, delete, and substitution operations are needed for the optimal alignment between insertion and deletion. All right. So, if you know that this can be calculated from the previous table itself. So, uh, let us discuss how to do that. So, as you can see, this is the table over here. All right. Now you need to do a process which is known as backtracking. So you need to get come from the final answer and trace a path back to this left bottom corner. So you need to trace that path and that will give you the optimal alignment. All right. Now how to trace that path? So that's basically at each cell you need to consider which possible cell did this value come from. All right. So for example, in this, the color scheme I have used is that blue is the current cell we are considering. So that is this top left hand corner, a top right hand corner. It is the final value. We'll start from here. So blue is the current cell, and red indicates the possible cell it has come from. Like these two are also possible. Like red indicates the correct cell which it came from. All right. So if you can understand why this 7, because obviously it could not have come from here, then the cost would have been 9. It also cannot come from here, so the cost would have been 9 again. So it definitely has come from here. So you know that the path backwards from this is to this one. All right. So you have these two now. Now you have to consider the next one. So let's understand what green means. So in green, I am denoting all the historical states which have already been considered. So we have already considered this one. So we don't need to look at it again. So that is done. Now we are at this cell. Okay, so the penultimate diagonal cell, and we need to find out where it came from. So again, using the same idea, it cannot come from this or this. So it must have come from here. All right, fine. We repeat that up till here, and if you notice something, okay, we repeat that up till here and also here. So if you notice something, so right now we are at this cell and we know that this one has come from this. And if you notice something, that up till this point the two words, like looking at them backwards, they are the same, tion and tion. So this is the common part of the two words. From here the words start changing, so you will see some differences from this point on. So how do they look like? Well, again, so from this 7 has come from this previous one. Now this 7 has come from this 5, right? And okay, so now we have a choice here. We need to understand where this one came from, right? So you have 4 on the left, 5 at the diagonal, and 6 at the bottom. So we need to find out where this 5 came from. So do not make the mistake that here we were seeing they were in a diagonal. You see this 5 and you hurriedly trace this one as the next path. So that is not the case. Why? These two characters are not same. E and L are not same. So when E and L are not same, so then you cannot apply the diagonal operation without adding cost of 2. So definitely this 5 did not come from this 5. So and it definitely did not come from 6. So where did it come from? It came from this 4. So can you understand how this thing shifted? Right. So this is what you need to be careful about. You need to try to understand which cell it came from. This is not a guess. It has definitely come from one particular cell. Like this is a deterministic path. It's not like that two people will come up with two different answers for this. The path will be exactly similar. So you need to carefully analyze which cell it probably came from. So this one came from here. Let's go on again. So the next one is easy. This 4 has come from this 4, obviously. All right. And then here, yeah, so let me tell one thing regarding this. So here you have a 4 which is not, so S and D are not same. So now looking at this, it seems like that it could have been possible it came from this 3 or this 2, right? All three are possible, but then you need to remember that we try to use the substitution operation wherever possible, because for optimal alignment substitution is one operation but you change two characters. The other operations, addition and deletion, they change one character each, so more number of operations are needed to do the same thing. So for example, you can do one deletion followed by one insertion, or you can do one substitution. Both operations have the same effect, but one substitution operation costs less in terms of number of operations. So that is why whenever you will see they are equal, you go diagonal. All right. So there we come to 2. And now from here, you know that we have to go down. There is no other way to go. All right. So this is the trace. Now, they have asked how many insertion, deletion, and substitution operations. So, as I told you before, horizontal is insertion, vertical is deletion, and diagonal is substitution. So, you can calculate from here how many movements were needed. So, we have two vertical operations from here to here and from here to here. So, these two are the two deletion operations. This is a substitution. This is an insertion operation. So horizontal is insertion. So you have one insertion, two deletions, and you have one. So this is one substitution. This is not a substitution because nothing changes over here. This is another substitution. So you have two substitutions, you have two deletions, and you have one insertion. All right. So that is the answer to this question. So you have one insertion over here, two deletions over here, and two substitutions over here. Rest of the things are not changing. All right. So I can take a few questions regarding like this spelling correction part if you have. So we can spend a brief time on that. So if you have any doubts regarding whatever I discussed just now, these two questions, so you can uh, yeah, so you can tell about them if you have any doubts. So somebody said, can I take one SI insertion? I can't understand your question clearly. You can unmute and speak if you want. Can I take first insertion? What do you mean by first insertion? I'm not getting that one. You can unmute and talk if you want.
Good evening, sir.
Yeah, yeah.
In some word, you write this table. Okay, I can't understand this table. In lecture, sir, show some method like take beginning word in upper and in lower the word which you have to change.
Hmm.
Okay, Um, I have some word, sir, and in that word, I want to calculate the instant distance.
Hmm.
So my question is, can I take first insertion if my first word are not matching and last word are matching, sir?
Uh, like, are you talking about the two words insertion and deletion over here, or are you saying how does it matter? Like, which side we place the words? Are you asking about that?
Yes, sir.
All right. Okay, so one thing you have to understand, the way we place the words do not matter when we calculate edit distance. So the edit distance will come the same. So
Okay,
going from insertion to deletion will take the same cost as going from deletion to insertion. Okay, like the
okay, sir.
words insertion and deletion over here. I'm talking about the two words. Okay,
Okay, sir. Okay,
so
sir.
the edit distance is the same, but when you change the order, the
Hmm.
operations might change. All right.
Okay, sir. Okay,
So in this case, you have seen we are getting two deletions and one insertion. Okay. So
okay.
if you just flip the words around, you will get two insertions and one deletion. So that
Yes, sir.
thing gets reversed. So if you
Okay, sir.
are asked to calculate just the Levenstein distance, it does not matter which side you put which word. But
Okay,
if you
sir.
are also asked about this optimal alignment, then you
Hmm.
need to take care of that. All right.
Okay, sir. Okay. Thank you, sir. Thank you.
All right. Any other
See,
doubts?
Shounak, see, we don't need the TION, both are same, right? In this, both the word
Yes.
TION is same. Okay.
Yes.
What
Yes.
you will do the change with insert and delete, right? So
Yeah.
yeah, the deletion will be like del operation will be I,
Yes.
and AND we can substitute,
Yes.
and SL also you can substitute.
Yes.
Then E will be it will be there. R will be drop, but like R will be delete, right? These are the operation we will do.
Yeah.
So in this, in that way, it's also correct. Or this box pattern is. I thought
Yes.
box pattern is
Yes.
little bit
Yes.
different.
Yes. Regarding that, yeah, like you might have seen. So I'm just going over to your like the slides which you have for which you have seen for this. So
Yeah,
you might have seen something like this, right? Are you talking about this?
exactly, exactly.
Yeah. So you can solve in either way. This is easier to do, but because this is a tutorial lecture kind of thing, so I went into the detailed solution so that you guys can understand how this
Okay,
is
okay,
working.
okay, okay,
All right.
okay. Thank you.
All right. So let's move on to the next questions. I have some more material to cover. So we have gone over this. All right. So, yeah, you have this question. So, what is the total count of unique bigrams for which the likelihood will be estimated? For this is a corpus. So, you have a corpus of these three sentences, and uh, they have asked is what is the total count of unique bigrams. So you just need to count the number of unique bigrams. So this is a very simple question, but the reason this question is there is that it will be needed in the questions after this. So let me just quickly go over this question because the later questions will be more important. So what we need to do, what is the only thing you need to remember is that you have to include the beginning of sentence and end of sentence tokens. Like you're familiar with these, I guess. So S inside angular brackets, this represents the start of a sentence,
Yeah,
and S like slash S inside angular brackets, that is
it's
like
end
the
of.
end of a sentence. Yeah. If you could just mute yourself now, I'll let you speak if needed after the questions are done. Yeah. Thank you. So you need to include the beginning of sentence and end of sentence tokens. That is the only thing you need to keep in mind over here. Another thing, okay, so let's come one by one. So the first bigram is like beginning of sentence and Alice. All right. Then Alice went to the cafe end sentence. Understood. So you will be given a corpus which can contain multiple sentences. And the question may be very simple like this: to count the number of unique bigrams. Unique bigrams, please remember. So we'll come to that. So the only thing you need to take care of is that in the question it may not be explicitly mentioned about these two tokens, like S and /S. Those may not be there in the corpus explicitly, but when you do any kind of processing, you need to take them into account. All right. So in some cases, you may see that they are mentioned specifically. That is for your benefit. They have given that. But if it is not given, you will have to consider beginning of sentence and end of sentence for any language model questions. All right. Also remember that end of sentence, beginning of sentence, this combination is not a bigram. All right, so you won't consider this one. So these are the only two steps you have to remember, and rest of the things you can just put in mechanically. So you add slashes like this beginning of sentence to the first of every sentence, and you add this one at the end of every sentence. Do not consider this bigram, and rest of the things will just happen normally. So the next one, it's Bob was waiting for Alice. So beginning of sentence and Bob, and here I've written down the full sentence. And this is the third one. All right. Now what the question has asked you is unique bigrams. So we need to remove the duplicate ones. So this is duplicate. When to, so that is a when to over here. When to, that is duplicate. And to the, that is also duplicate. So we have a total of 20 bigrams, but unique bigrams are 70. All right. Okay. So a trigram language model is a dash order Markov model.
It is
So
second.
yeah, so correct. The answer is second. Why? Because by definition an n-gram model is a n-1 order Markov model. So if you have a trigram model, for any token, you are trying to find out its probability given the previous two tokens, right? So that is how a trigram model works. So based on that, the conditional part of that thing is based on two tokens. So that is why it's a n-1 order. So a trigram model has two tokens in the conditional part. So you have x3 given x1, x2. So that is why it's a n-1 order Markov model. All right. Now the next questions, we'll do 4 questions now, which will be all based on this corpus. If you can see that there is a corpus over here, and as I was saying, in some cases the beginning of sentence and end of sentence tokens may be clearly given to you. That is for your ease of understanding. But remember, in every question they may not be there, but you have to consider them. All right. Otherwise, your equations will go wrong. Okay, so this is the common corpus. Now we will go into each question individually. Okay, so a little big, but let's go slowly over it. So you have to consider a trigram language model. Trigram language model means probability of x3 given x1, x2. So you have to consider the previous two tokens. Now they are saying you also consider that there is this non-existent empty word w minus 1. Now why it's there, I'll come to it, but just consider. So like if you just consider any part, so just consider the first sentence. So then what they are saying is this is w1, the is w1, and /s is w0, and there is an imaginary token over here you can consider, which is w minus 1. Why imaginary token? Why do we need to think about an imaginary token? Well, uh, the idea is that because we are doing this trigram model, so you know the probability estimate of the sentence S, which is given as words W0 to Wn plus 1. So you have W0 as this beginning of sentence and Wn plus 1 is end of sentence. So there are n words. We are then giving W0 and Wn plus 1 as the beginning of sentence and end of sentence markers. And you need to find out the probability estimate. So when we expand this, so PW0 n plus 1, this is a trigram language model. So the first word that you will consider is W1. W1 conditioned on W minus 1 and W0. That is why the W minus 1 was there. It is just for notation purpose. In reality, you don't have any W minus 1. In the equations, it will not come also. But this is just for completeness purpose. Alright. So it's a notation you can think of. Don't let these kind of notations throw you off. Okay. Whatever you know how to calculate these things, the same things you will have to apply. Don't let these kind of things throw you off. So often questions are like that. They give you these kind of details which may not be unnecessary, but they are not really very important, but they can sometimes throw you off. So don't get uh, surprised or something like seeing such things. These are whatever you know, this is reiterating the same thing but in a mathematical notation. So P, or like the probability of the entire sentence, is given in this way. So we go from W1 to Wn plus 1 and we condition it based on previous two tokens. So given all this, you are asked to find the probability of this sentence S, where the sentence S is Michael and Zach played at the playground. So this is the sentence and this is the corpus. So each individual probability you will calculate from this corpus and then put in to calculate this final probability which they have asked you. How to do that? Okay, let's go over it slowly. So you need to calculate the probabilities of every individual trigram. All right. So you look at this sentence S which they have given you. You need to calculate the probability of every trigram in this. So quickly, W0 is this one. W minus 1 is the imaginary word and W1 is Michael. So when we try to calculate this probability, the first term is PW1 given W minus 1 0. So W1 is Michael, W0 is begin of sentence and W minus 1 is this imaginary token. So as I said, this is just a notation. When you calculate, you just need to calculate this because that token does not exist itself. It is just there to complete the mathematical notation of a trigram model. When you calculate directly based on this. So because there is just one single token before it, you condition it based on that. Alright. How do we get 1 by 5? So what you need to say is that whatever you have after the bar or like after the condition, whatever is the like the two tokens which you are conditioning on, you find them out in the corpus. So if you are talking about beginning of sentence, there are 5 such tokens in the corpus, right? And then you need to calculate the probability of how many times it is followed by Michael. So if you see out of 5, only one time it is followed by Michael. This is this case, right? So the probability is 1 by 5. Look at the next word, which is and. So now this is probability of W2 given W0 and W1. So S Michael, like begin sentence Michael, and you have to calculate the probability of and given begin sentence Michael. So you find out how many such combinations are there. So beginning of sentence and Michael, there is just one example in the whole corpus, right? So when that is the case, you have 1 by 1 because S Michael, it is followed by and. So this is 1 by 1. I'm just going over it slowly so that you can clearly understand how to calculate these things. It's quite simple. It's just about understanding what the question is asking you to. The calculations are not very tough, but you need to understand and you need to do it in a mechanical way. Don't get distracted in the middle because then one small calculation can, a small mistake in calculation can cause bigger errors into the problem. So that is why be careful. Simple calculations, do them patiently. So the next is obviously that is Zach given Michael and. So Zach given Michael and. So what is the probability? If anybody can just mention, so that you also participate in this. So probability of Zach given Michael and.
It is 1.
That is correct. So you have two cases of Michael which is the second sentence, Michael and the last
Yes,
sentence,
yes,
Michael and.
correct, correct.
So Zach given Michael and is 2 by 2. The next one is played given and Zach. Alright. So if you see and Zach is over here, and Zach, and Zach. So only one time it is followed by played. So 1 by 3. We do the other ones in the same way. Alright. And how far will we go up to? We will go up to end of sentence given the playground.
Can you please repeat the Aunt Jack given played?
I didn't get you.
No, I did not get that. Aunt Jack given played. The fourth one.
Played
Yeah,
given
yeah.
and Zach.
Yes.
So if you see, find out where you have this thing and Zach. So second sentence and Zach. After that you have went. Then you have fourth sentence and Zach. After that you have played, and then and Zach. After that there is were.
Yeah, yeah.
So
Got it. Got it.
so out of three cases, only one time it is followed by played. So played given and Zach. All right. So you have calculated
Yeah.
the probability of every individual trigram. All right. So finally, you just need to multiply them together. And the answer is 1 by 60. So you just multiply the probabilities of the individual trigrams.
So it is for diagram. In the same case of diagram, it will be only one word, right?
Yeah. In bigram, you will just consider only one word. So like for the same sentence, it will be Michael given start. That will be same. Then you will
Yeah.
have and given Michael, Zach given and given Michael,
Beginning to.
Zach given and played given Zach, like that.
Okay. 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 Okay.
Next question. So given the same language model, what is the perplexity of sentence S? Sentence S is this sentence: Michael and Zach played at the playground. So you need to calculate the perplexity of this sentence. So if you know how to do it, I'll just wait a little bit. So if anybody can attempt the answer, and then we'll. So I guess this is a bit unclear still. All right. So the perplexity of sentence S. So this is the correct answer, and how we are coming to that is, so perplexity is probability of the sentence to the power minus 1 by n, where n is the number of words. Now you have to remember one thing: when you calculate number of words, you do not include begin sentence and end sentence. That is why if you see their indices, the actual words are indexed from 1 to n, and begin sentence is given index 0, end sentence is given index n plus 1. So total number of words is actually 1 2 3 4 5 6 7. Sorry, I just mentioned wrongly. Here you have to actually take both begin sentence and end sentence. So if you take all of them, you have 9 words. And yeah, So this is how we get this value. Yeah, you have to take the begin sentence and end sentence. All right. So okay, so in case you got confused, let me just say once again. Here, whatever is the notation, W0, Wn plus 1, probability of W0 given n plus 1 and all these things, these are for calculating the probability. When you do the calculation for perplexity, then you need to take entirety of whatever is inside over here. So that will include begin sentence and end sentence. So given that you are including them, so you will have a total of 9 words, and thus this is the value. So 60 to the power minus, so 1 by 60 to the power minus 1 by 9, which finally gives this value 1.576. Okay, let's move on. Now we have Laplace add-1 smoothing. Okay, so you have given a new sentence. Bob learned science at the school. Okay, and you have to calculate the like the same values probability estimate, but this time with Laplace add-1 smoothing. All right. So for doing Laplace smoothing, you need to find out the vocabulary size. I hope you know that. So what is the vocabulary over here? Vocabulary is number of unique uh, bigrams. Because this is a trigram model, so you will have to count the number of unique bigrams for finding the vocabulary size, which will be added for normalizing. So if you know that when we do Laplace add-1 smoothing, we add 1 to the numerator and we add the vocab size to the denominator. So first we'll calculate all unique bigrams in the corpus. Remember, this counting unique bigrams is for the corpus, not for the sentence you are given. So you need to calculate the vocabulary size in the corpus. So we'll just list out all the bigrams. If you remember, this is just the first one is simply begin sentence token. We are just writing the W minus 1 for notation's sake. If you remember, this is actually empty. So it does not change anything. All right. So here I am just listing down the total number of unique bigrams one by one. So each sentence at a time, I am listing them down. And here I have not repeated the bigrams. So like all of these are unique. So you at the end, the last two sentences, you will see a lot of common bigrams are there. So here I have not repeated them. I have just listed out the unique bigrams. All right. And yeah, here maybe there is a problem with the space, but actually in the question this Bob, after Bob there is a space, so like the comma is given as a separate word, so to say. So that is why we have this over here. Maybe mistakenly over here the space did not come, but actually in the main question this is with a space. So that is why, sorry, that is why like this Bob and this Bob will, like, it's not like Bob comma becomes a new word. This is like there is a space over there, so that is why we have unique bigrams 28. All right, so that is the vocabulary size. Now you will have to eventually calculate the probability. So we repeat, just as we did in the previous one, we repeat the same process, but this time you need to add 1 to the numerator and add the vocab size to the denominator. Alright. So again, this is Bob given start of sentence. So 2 times Bob comes after start of sentence and 3 times it does not. So 2 out of 5 would have been the value normally, but because we are doing Laplace smoothing, so we add 1 to the numerator and 28 to the denominator. So we get 1 by 11. Similarly, the next one, learned given begin sentence Bob. So if you look at the corpus, nowhere there is begin sentence Bob and then learned. this, like, it does not occur. So that is why it's 0. And begin sentence Bob comes 2 times. So that's why the 2. And so 1 by 30. Same again. Nowhere Bob learned science. These 3 words come together. That's why we have 0 again. And 0 over here also. Because Bob learned is not there in the corpus. So that is why we have this Laplace smoothing technique to avoid situations like 0 by 0. So you are adding 1 to the numerator and 28 to the denominator. Similarly, again, there is no where in the corpus where you have learned science. So learned science is not there. So again 0, 0. Same for science at. At the. So there are some examples of at the. So the playground at the school, and Bob and Zach played at the playground. So school comes one time after at the. So you have this 1 by 15. And this is the last one. Alright. So we calculate probability in the same way. You just multiply them together and that gives us this value. So E here means 10. Like this is not the logarithmic E. Alright. So this is the scientific notation, so to say, like how we write in programming languages. So E to the power minus 10 actually means 10 to the power minus 10. So 5.937 into 10 to the power minus 10.
Sir, can you repeat the last line?
So if you see the notation over here, 5.937 into e to the power minus 10, it's written over here, right? So just one thing is that this e over here is not the logarithmic e which you are used to, like which you have used in logarithms and mathematics, like that Euler's constant e, which has 2.7 something like that value. So this is not that. This is actually the scientific notation which is used in programming languages also. So when we have to do like when we have to write numbers which are very weird, like to the power minus 10 means 0.0000, like lot of zeros. So instead of writing it like that, which becomes unreadable, we write it in this form. So E actually here stands for 10. So like 10 to the power. E to the power something here stands for 10 to the power something. Alright. Okay. Again, next question. So you have the same corpus, but this time you have a bigram language model without smoothing. So which sentence has the highest probability estimate? So here they have asked you to find out the highest probability estimate among these 4 sentences. Okay. So now let me just give a few ideas about this. So you already know, I like the previous examples have shown you how to find out probability of a sentence. Fine. We have done the previous examples using a trigram language model. You can just do it with a bigram. That will be even easier. But you could do one thing, that is you calculate probabilities individually for all of them and then you see which is the largest. Probably that is what should be done. But when you have MCQs, sometimes the MCQs are designed in a way that they can be solved very quickly if you look at them carefully. So somebody actually came up with the answer C. So the answer is C and you don't need to do a lot of math to find that out, because there are some words in the other examples. These words actually are not or do not occur in the bigram way in the corpus. Like for example, Michael played at the playground. If you look at the corpus, do you anywhere see that the word played comes after Michael? It is not there. So what it means is that when you do the probability, this one will come to 0. You do not have smoothing over here. So this is 0 actually. If you look at the next one, Bob went. In the corpus, you do not have Bob went. So again, probability of this sentence is also 0. If you look at the last one, Zach, like Zach went was there, but Zach given like the start of sentence. So in the corpus Zach, no sentence starts with Zach. So that is why probability of Zach given start of sentence is 0. So the probability of these three things are 0. So automatically, because this is a MCQ question, you can directly say the answer is C. But just for sake of completion, I have also done the calculation for C over here. And actually all the words in C, like all the bigrams are actually there in the corpus. So we get a non-zero value, which is this. Okay. So I'll cover one more small example and then I'll take up a few doubts. That is also related to language models, not this particular corpus, like the questions regarding this corpus are done. So this is like a normal mathematical numerical, so to say. So for a corpus, like this is a new corpus, this is not related to the previous ones. For a corpus, maximum likelihood estimate for the bigram battery life. So for the bigram battery life, the probability is 0.27 and frequency of battery is 800. And after applying Laplace smoothing, the MLE becomes 0.025. So without smoothing it is 0.27, with smoothing it becomes 0.025. You have to find out the vocabulary size of the corpus. Because this is a bigram model, when we do Laplace smoothing, we find out the total number of unique unigrams, like not bigram or trigram, we find out unique unigrams, all like unique words. Each unigram is a word. So we find out unique words which is actually known as vocabulary. So there, like, don't get confused. Vocab size is like, you will find that out when doing Laplace. Very simply, so PMLE given of life given battery is the frequency of battery life divided by frequency of battery. Now you know frequency of battery is 800 and the PMLE is 0.27. So frequency of battery life is 216. Now when we do Laplace smoothing, so PMLE Laplace smoothing is for life given battery is frequency of battery life plus 1 given divided by frequency of battery plus V. Just like how we did the previous ones. So you add 1 to the numerator and V to the denominator. So you have all the other values, you plug it in the equation and you get this value of V. Okay. So yeah, now I can take some questions from these language model parts. So if you have we only add 2 here. I did not get your question. Yeah, you can speak with the mic. That will be easier.
Sir, for add to smoothing,
Huh.
we can add only +2 in this equation, no?
Yeah. So
Am I audible, sir?
yeah.
For add to smoothing, may I add only 2 in this equation, no, sir?
Yes.
Okay.
Yes.
Yes, sir. Thank you, sir.
All right.
It is instead of one, we will add two.
Yes.
So bigram.
Yes. All right. Any other questions? So, like, were these questions of probability estimate, were they clear to you? Like, you have to do simple calculations. Just remember the steps you have to follow. All right. And don't get thrown off by such terms. Sometimes you will get a very big question with a lot of things written, but end of the day you have to do whatever you would have normally done. So these things are there to throw you off sometimes. So read them, try to understand what they're saying, but don't get thrown off. Eventually, you will have to do something which you have already been taught. So, yeah, that's the thing. Okay. And remember those little things, uh, such as counting the beginning of sentence and end of sentence when you do perplexity and things like that. Considering these two things when you have them. Yeah,
Sir,
so
can you go to the next question?
this one
Uh,
or the next one?
yes, sir. Sir, show the calculation.
This one,
No, no, sir. Next question.
advanced
Another one.
smoothing.
Sir, not this one. Yes, sir. Yes, yes. Sir, can you show the probability calculation of the first example, first line?
So
I have some doubt.
Bob given W minus 1S. This one you are asking.
Yes. Yes, sir.
So this one is basically W minus 1. If you look over here, let me just go to that question. W minus 1 is a non-existent empty word. So
Yes, sir. I know.
it is like as if that word does not exist. You are just putting it there. So this effectively means beginning of sentence. Alright.
Yes.
So probability of Bob given beginning of sentence. So if you look over here, beginning of sentence occurs 5 times. And Bob comes after that 2 times. Right. So in the
Yes.
numerator you have 2, in the denominator you have 5. You would have calculated 2 by 5 as the probability if you did not have the Laplace smoothing. Because you have the advanced smoothing, you will add 1 to the numerator and v to the denominator. That is why we are getting 2 plus 1, 3 divided by 5 plus 28, which is 33. So that is why 1 by 11.
Sir,
Okay.
could you please show question number 8?
This one?
Yes, sir.
Yeah, so I'll just repeat once more. Since this is a MCQ, you can do some, like there are some tips and
No, no,
tricks which we
sorry,
apply.
sir. Sorry, sir. Sir, question 9. Question 9. It's clear.
This one?
Yes, sir.
Yeah.
Sir, why we added plus 1?
So,
Maybe-
okay. So let me just repeat this once more. You have a given corpus, all right?
Yes, sir.
And for that corpus, you have first given these information. So MLE, maximum likelihood estimate, which is the probability, basically the thing which we have been calculating so far. So the probability of this sentence, so to say, battery life, or like these two words, probability of these two words is life given battery, because this is a bigram model. That is why life given battery, that is like this. In the next part, you see, after applying Laplace smoothing, the MLE for the same word, battery life, becomes this. So the word remains the same, life given battery, but this time we are doing PMLE Laplace smoothing. That is why in the formula you have 1 added in the numerator and V added in the denominator.
Okay, sir. Fine. Thank you.
Okay. All right. So, any more questions? All right. So, a lot of you have been asking about where the materials will be uploaded. So, have you not got any communication from the like any official mail or something from NPTEL, like where you can access them?
It should be under course, my course in LMS.
Sir, could you please provide the recording of this class?
Yeah, actually we are like from my end I am giving the recordings, but I don't know whether they have been made accessible to you or not. So I'll just ask the professor about this thing. And uh, so I am in your I have already joined the course in NPTEL. And so if I get an update from him, I'll just like tell you, because we
No,
are uploading these things.
no, sir. I already seen your first video and your document. So it is there. Your in my under my course. The One second, I'll tell you where is there.
Okay.
That is, yeah, under course outline. It is there under problem solving session.
So
That will be,
actually, I
yeah,
am not fully sure about the logistics, but as you said, I from my end I have uploaded the things. I'll just confirm about that accessibility, and if you guys everybody is not getting access, then I'll raise it with the professor. But ideally, it should be accessible. Like as
yeah.
he said, that
Yeah, it
area.
is accessible. Yeah, it is accessible.
From my
Okay.
end is I'm able to access.
Okay, okay. So, as you said, like, if you could just write it in the comment section, like where to find, so that others can also see. Uh, just write it down over there.
Yeah, okay.
So there is a simple link like problem solving session. In that link, if you open that link, uh, you have to click over there. Then it will show you the Excel sheet kind of
Yeah,
sheet where
Yes,
exactly.
you,
yes, yes,
yeah.
yes.
Exactly.
So in the Excel sheet, the video links and presentation video links are
Both will be
given.
there.
Okay. So, all right then. Thank you. And yeah, you are saying something. It's not audible. So, Jawad, you are not audible actually. If you want, you can write in the chat what you. All right. I guess there's. I guess we are done for today. So we will. Oh, any reference guide or any site? I I guess the best form of reference are the slides which you are getting. If I don't know any one comprehensive guide for the entire thing. If there is any particular topic which you are finding difficult, then just you can look up that topic on YouTube and see anything. Like I don't know any comprehensive guide for the whole thing. Like the slides are more or less covering all the materials. So if you have any problem in any particular area, you can look up that area in YouTube.
So you are going to upload these today's slides also, right?
Yes, yes, yes. Like all everything will be uploaded. So, no,
So
no
today's
issues.
slides will be immediately available after this session.
I don't know if it will be immediately available, but I will upload right. So I guess it should be.
No, sometimes it is taking time.
Because
Maybe one.
the officials they do these things like on from our end we students just have to upload the things. All right. So you will get them definitely. That is not a issue.
Okay, thank you.
Okay then.
Sir, email ID, please. So it will be there on
Yeah.
email ID. Your email ID, please. In case in doubt, I'll ping.
Okay. Although the doubts should ideally be addressed in the doubt forum, but if there is something urgent, you can mail me here. If it is possible, I'll try to respond to
Yes.
your
Thank
comments.
you.
All right. Okay. Uh, thank you everyone, and we'll meet again next week.